Recording in progress.
So let's get these two. So what happens if the springs are at an angle? If you remember, that was a result when the springs are at an angle. Spring at an angle can be treated as a spring of k cos square theta for small changes. Let's get these two. Hello, are the scans on? So how do we do this thing? So this can be replaced by two vertical springs. Right, this will become k cos square 60, which is k by 4, k by 4, and k. All three are in parallel, so k equivalent will be 3k by 2. Time period will be 2 pi root over m by 3k 2m. What about this thing? We have done this kind of stuff. So when you keep the 2m block here, what happens? This was your initial position. Be careful, this was your natural length. This was mg by k. This would be your extreme position because you're starting from rest. Two m and m. This will keep on stretching till mean position. Mean position is the point where the net force is 0. This will be 3 mg by k. This is your mean. So the distance between the mean and the extreme position is your amplitude, which is 2 mg by k. And the time period will become 2 pi root over 3m by k. Clear area. The moment you attach the block, you start from rest. If you're starting from rest, that means you're at the extreme position. Find the natural length, find the extreme position, find the mean position, and you're done. Clear with this? Let's get these three. So this is oscillating. You kept one more block stuck to it. So this block is oscillating in SHM with amplitude plus A minus A. When it is at x is equal to root 3 A by 2, you kept a block. Find the new time period and the amplitude. Time period is easy. Amplitude is a good one. K, you already know how to do reduced mass. L is also a good one. Let's see. Thing involves little work. So you're keeping another block at x is equal to root 3 A by 2. Now remember, when you're sticking things, E is equal to 0 means you can't conserve energy, but you can conserve momentum because spring is non-impulsive. So when you're at x is equal to root 3 A by 2, your speed will be omega into root over a square minus x square, which is 3a square by 4, which is a omega by 2. That will be your speed. Then what you're doing, you're keeping one more block on top of it. The moment you put a block on it, the speed will change. They will go with a common speed. Conservation of linear momentum, that will become a omega by 4 because the mass is doubled. Right? Now, for the new question, the question has become like this. We have a block of mass 2m. X is equal to 0 is still the mean position. This position is still x is equal to root 3a by 2. Now the speed here is a omega by 4. Clear this? And what was this omega? Omega is equal to root over k by m. Now from the formula, we know this formula must be, velocity must be omega dash into root over the new amplitude square minus x square. Do you agree with that? For the new SHM, there will be a new omega dash, there will be a new amplitude, but the x coordinate is still the same. This will be a omega by 4. And what is the new omega dash? Omega dash will be root over k by 2m. So this guy will be a by 4. Omega will be root over k by m. This is k by 2m, a dash square. That's what we are trying to find. X square will be 3a square by 4. K by m 4 goes off. This will be a by 2 root 2. The square. a dash square minus 3a square by 4. So a dash will be, that will be 3a square by 4 plus a square by 8 multiplied 2, that will be 6 plus 1, 7a square by 8. Is that clear, everyone? Understood what we did? The mean position is still x is equal to 0 only. The moment you stuck the block, the velocity became half of the initial velocity. So this velocity must be equal to omega dash into root over a dash square minus x square. This formula is still valid, but the catch is the omega dash changed and the a dash changed. Is that clear, everyone? And that a dash is your new amplitude. All clear with the process? That would be a faster way. In case you didn't like this, you can conserve energy. Then you will say this is the initial state, this is the extreme position amplitude a dash. Kinetic energy plus spring energy is equal to, you can conserve that. That also works. That will be lengthy though. K ka answer, you know, time period will be 2 pi root over mu by k. Mu is the reduced mass, 3m, 2m by 3m plus 2m. What is this thing? What is the maximum amplitude? If you look at the block here, the normal reaction n, mg, and your acceleration, if n becomes 0, then you will lose contact. Right? And a is equal to minus omega square x. So n is equal to mg minus m omega square x. So if you don't want to lose contact, n must be greater than equal to 0. Then you will get x must be less than equal to g by omega square. This is your maximum amplitude. Simple way to say this thing is the maximum acceleration omega square must be equal to g, isn't it? If you exceed g, then the platform will go faster than g and they will lose contact. Clear? That's another standard equation. Huh? L is a very standard equation. Find the acceleration so that the block will lose contact or block does not lose contact. Any doubts on this? Let's get these two. We have a block inside a liquid and there's a spring also. Find the time period. We have a block of side L. The base area is A. The container area is 4A. Find the time period for small oscillations. U-shaped pipe LLL, area A. Find the time period for oscillations. Fluid mechanics, SHM. Hope you remember. You have seen all these kind of models. B, I changed something. I gave you the container area. In fluid, I did a question without the container area. So how does the container area affect your problem? Get them. He's a good one, right? Get them all, get them all. I'll give you 3 minutes for all three. 3 more minutes. Like I said, no need to solve the whole thing. You can just write the main equations and leave it. Solving part that is fine. I know you can handle it. So it's like if I said 3 minutes, it's like 3 minutes to figure out what to do and another 3 minutes to solve. So that solving part I'll leave it to you. Just get me the main equations and you're done. A is easy. So when you would push it by X, now remember, we are not interested in the buoyant force, we are interested in the change in forces. So this part additional, it will go X inside. So that additional buoyant force delta FB will be rho liquid area L square xg, that is an additional buoyancy force. The spring force will be additional kx. So initially the spring is already compressed. How much? We don't want. What we are interested in is the change in forces. So kx plus rho L square xg is equal to mass into acceleration. There you're done. A is equal to minus k plus rho L square g by m into x. That's your omega square. Clear? So when you push it by x inside, so that's what you do. Push the block by x inside. Find the extra buoyancy force, find the extra spring force. That extra force must be creating the acceleration. What about this U-shaped? U-shape, same story. Push one side by x. Now when you push one side by x, what happens is initially the level is here. This liquid will go down by x, but the other side will rise by x. So this total difference will be x and x. That means the restoring force is created by 2x liquid. So the F restoring will be rho of the liquid, area of the cross section, 2x into g. This must be equal to mass of the liquid into acceleration. That would be rho liquid A 2x g. Mass will be rho liquid area, total length is 3L. So A is equal to minus 2x by 3Lg. That's your omega square. You're done. Clear with this? So be careful with that. If you push one side by x, the other side will rise by x. So the total difference will be 2x. The 2x liquid will create the restoring force. What about this guy, the B part? The catch here is when you push the container by block by x inside, the liquid will get displaced. Now, since the areas are comparable, liquid will also rise. So two things will happen here. Let's conserve the volume. So when you push the block by x further, so you're pushing it by x here. This liquid will go to the sides and this will result in the increase in height here. Let's call this thing y. So a into x must be equal to 4a minus a into y. Does that make sense? When you push the block inside by x, you displaced ax liquid. Where will this liquid go? It has to go somewhere. That liquid will get displaced. I hope you're able to see that picture there. This liquid will get displaced from here and will go to the sides. So the liquid metal container will increase. So y will be x by 3. That means whenever you pushed the block by x inside, when you pushed it by x inside, let's say initially this was the height, you didn't actually push x only inside. You pushed x inside and the liquid level went up by y. Are you getting what happened? So whenever you push this by x down, the liquid level will rise by y. So that entire buoyancy force delta FB will be rho liquid area x plus y into g. That is a catch. Are you clear with this? If the base area is not given, then we will assume the area is so big that y is 0. Are you clear with that? That is the difference. If you're not giving the base area, then I don't know how to do. So we will assume the container is so big, the height is negligible, the rise is negligible. So then you're done. So this is rho L A 4x by 3 g is equal to mass into acceleration. You'll get the answer. So y is the increase in the liquid level. Is that logic making sense, everyone? So end of the day for the block, what will think? The block will think, boss, initially I had some depth. Now the depth increased by x plus y. Where I went x inside, but the liquid came up y. So in total, I increased by x plus y. That will generate the entire extra buoyancy force. So be careful whenever areas are given, and I hope you understood why I took 4a minus a. Because this area already is a, you are increasing the water level besides, na? So that should be the remaining area. You can't increase the height at where you're standing. Clear with this? So if I give you a1, a2, then the answer would have been like a1 into x is equal to a2 minus a1 into y. That is how it would have been a general equation though. Let's get this thing. We have a rod hinged at a distance x. Find x for minimum time period. We have a solid sphere, spring at the top. Find the time period. So for this thing, I can ask you find time period and find maximum amplitude. Quotient of friction is mu. So a rod is hinged at a distance x from the center of mass. Find the hinge x for the minimum time period. That's a decent main circle question. Right, Devant. Yeah, first was easy. L by root 12, if you remember. Standard question we did in the class notes. So what's the time period formula? Time period is 2 pi root over I by mgd. D is the distance from the center of mass, I is the moment of inertia. That will be 2 pi, moment of inertia will be ml square by 12 plus mx square, parallax theorem by mgx. You have to maximum minimum that function, you have to do that. That will be L square by 12x plus x differential. You get x is equal to plus or minus L by root 12. There are two answers. You can put it up or down. What about the B part? Get that, I'll give you a minute. I'm more interested in the amplitude actually. Both are good. That would be a decent more than one choice question actually. Find the time period for oscillations and the maximum amplitude. Rugved, what happened? Didn't understand the question.
It took some gestures from my handwriting, sir.
Okay. Hmm. Let's see. So what do you do for this thing? Displace the center by x. If you displace this by x, the topmost position will displace by 2x. Draw the FBD of this. Then the spring force will be k into 2x. Hope you remember that the topmost point, if there's no slipping, you'll go double the distance, right? And there'll be a friction here. Since it is not slipping, take the torque about the bottommost point. And we will take acceleration a forward, alpha this way. So a should be always in the direction of x. If I take torque about a, friction will go off. That's what I want. I don't want to deal with that friction there. So k into 2x into 2r minus moment of inertia I about alpha. It's a solid sphere. That is mr square plus 2 by 5. So 7 by 5 mr square alpha. And we know a is equal to r alpha. It's not slipping. So this will be 4kx is equal to minus 7 by 5 ma. There we get the answer in one step. So taking the torque about the bottommost point saves you time when it is not slipping. Once you got this, we know friction minus k into 2x is equal to mass into acceleration. From here, we get friction is equal to 2kx, and ma will be that will be 20 kx by 7. That means if I'll get 7 to 14 minus this, so friction is actually negative. I took the direction wrong. Friction is supposed to be in that direction, interestingly. So this would be how much? 7 to 14 minus 6kx by 7. So just take the magnitude. This should be less than equal to mu mg. So x ka value must be equal to 7 mu mg by 7k. If you exceed this value, friction will become, it will become kinetic and the block will start slipping. And if the sphere starts slipping, it is not SHM anymore. You lose energy. Clear with that? So whenever they ask you questions about maximum amplitude, it is always that only. The friction is the limiting case. If you pull the spring too much, then you're asking for so much friction, the friction can't provide that value and the sphere will start skidding on the floor. Clear with this? That's a good one. So you can, let me ask you one more like that. Same question. Let's say instead of this, what if I keep a plank? And we have a spring here. Just get the time period. Plank mass m. This is a solid cylinder, mass m radius r. There's no slipping anywhere. Find time period. This is slightly tougher. This is a tougher, more than mains definitely. But since we are looking at it anyway, the idea is the same. Let's see how will you handle this. Find the time period for small oscillations again. So if you oscillate, right, you got 2 3 minutes. Same story. Start with that. Let the cylinder move by x. You don't know what to do. You always start like that only. Let the cylinder move by x. Draw the FBD. Start. By 8m by 11k. Let's see. I don't remember the answer. Let's push this by x. Right? So this guy will go by 2x. So this thing tells you a few things. So if this guy has acceleration a and this guy is alpha, the Planck will go with a 2a. So Planck acceleration is double. So draw the FBD. Spring force kx. There will be friction here. Let's call it F1 and the acceleration is 2a. So for the sphere, this friction is F1. There is a F2 here and this acceleration is a and alpha. Take the torque about the bottommost point. Torque about a, F2 ka torque is gone. This is F1 into 2r. This is equal to minus IA alpha. But we also know F1 minus kx is equal to, that is 2kx. F1 minus 2kx is equal to m into 2a. Take that F1, dump it there. So that will be 2kx plus 2ma into 2r. IA will be 3mr square by 2 alpha. A is equal to r alpha. So 1r goes off. That will be 2kx plus 2ma is equal to minus 3ma by 2. There you got everything. So A will be 4kx by 2 to 4 plus 3, 7m. Did I miss something? 2r. There is a 2 also, no, sitting? Yeah. And that will be 4kx. So that will be 8kx. And that will be 8 plus 3, 11m. You're right, Niharika. I missed a 2 there. This is a solid cylinder record. Clear the steps. Problem is lengthy, but if you know how to do the steps, it won't take more than 2.5 minutes. That's what I'm trying to show you. You can be as fast as this. That's what I'm saying. You can be this fast, when you know how to do. If you're sitting and thinking the equation, then you're gone. And these kind of models we have done. And if you see the process is the same, draw the FBD, start equation, constraint, solve. It's more of a rotation problem. In the end, SHM comes and hijacks the problem. The whole problem is actually rotation. Next time, we have a rod there, mass m length L, there is a spring L by 2. Find time period for small oscillations. We have a rod placed on a fixed hemisphere at the midpoint, slight disturbance, find the time period for small oscillations. So this rod will oscillate left and right like a seesaw. These are main real equations again. The previous one was an advanced one. So yeah. It doesn't mean we should not do any advanced things. Who knows? Mains paper, who said it will be easy every time? What if this time advanced means people have gone crazy and they, smash you guys in the mains paper? What था ना last time NEET में? NEET paper so they got slaughtered. People were expecting 180 out of 180, got 80 marks, 70 marks. But again, overall cutoffs also went down. Medical mein people used to get a medical seat, people used to get 720 out of 720 in medical. So people were expecting 680, 690 out of 720. They scored 530s and 520s. But still they got a medical seat. So they got a seat which was supposed to come for 650. They got it for 540, 550. So cutoffs went down. It'll be a good thing if the paper comes tough. You guys will survive. Meaning instead of you getting 90, you will get 60. But the other person who's supposed to get 70 will get 20. So paper should be hard. You will mess up, but others will mess up much more. Then your rank improves a lot. Mutual destruction. In chemistry, it is called what? Leveling effect. Yeah. I hope you know. I hope you know what is leveling effect. When you take an acid like acetic acid and HCl, right? And if you give a good environment like water, which is a polar solvent, both of them will behave like strong acids. But when you put them in benzene, you will see who is the true acid. Acetic acid will not release H+, but HCl will still release. So what it says is when the conditions are good, everyone behaves like they're a hero or heroine. You know your true character only when things go hard. So how strong is your subject? You will know when the paper is tough. When it is easy, everyone will feel like, oh, I am smashing the paper. So how do we do this thing? Ninth one. So displace it by small theta. Again, the small theta is important, so you can't treat it like an arc. So this spring here will get stretched by L by 2 theta. So when you draw the FBD, again, remember, we are writing increase in forces, okay? Mg, the initial Mg was already balanced by the spring force. We are not considering that. So this will be K into L by 2 theta. So this is the change in spring force. You're always interested in the changes. So initially the spring had actually some elongation. Spring is not a natural length. The Mg ka torque is balanced by the spring. We don't care about that. So now the torque will be K L by 2 theta into L by 2. There is a torque about the hinge. Must be equal to minus ml square by 3 alpha. We get alpha is equal to minus 3k by 4m theta. That's your omega square. You're done. What about this guy? Displace it by small theta. Then your rod becomes like this. So your centrum mass will be somewhere here. Again, kind of an approximation this thing is. So you displaced it by small theta here. This is your mg vector. So you're taking torque about this point here. So this is the perpendicular distance here. So torque about A will be mg. That length will be some RD theta is equal to minus IA alpha. But since A is very, very close, you can almost approximate it to be ml square by 12 only. And that is the whole point of small theta. So technically speaking, IA should have been ml square by 12 plus m into r theta whole square. But the theta is very small, so we neglect it. Clear with this? Let's get these 4, 5. Half ring. I think this we did in rotational mechanics, but let's do it again if you remember. Time period for a long pendulum. There is a formula. Let's see whether you remember this. We have a pendulum of length L. There is a spring connected. If I displace this way, find the time period for small oscillations. We have a hollow shell filled with water. It continuously leaks. What happens to the time period? We kept a sphere of rho b inside a liquid. Find the time period for small oscillations. SHM is one beautiful chapter actually. If I have to revise only one chapter in the entire physics, I'll revise SHM. You can bring everything inside it. Nere man. First one nahi hai. First one you got a good answer. First one is actually 2004 ka JEE question tha. Almost 20 years back. I was preparing for JEE then. I was in 11th standard, I guess. Get them. I'll give you 4 minutes. C is a good one. Instead of a spring, if I put a rubber band, it becomes an advanced question there. But okay, let's do it for a spring now. Try. Tenth one. First one is a physical pendulum, 2 pi root over I by mgd. So where is the center of mass? Somewhere here. This is the center. Let's call it O. This distance will be 2r by pi. Then this distance will be r minus 2r by pi. Let's call this thing A. IO is mr square, which is ICOM plus m into 2r by pi whole square. IA will be ICOM plus m into r minus 2r by pi whole square. Subtract them. From here, you will get IA. Then when you apply the formula 2 pi root over moment of inertia about A by mgd, that would be r minus 2r by pi. And the interesting thing about this question, you will get the answer as if you took O as a centromass and solve the problem, you'll get the same answer. If you have taken O as a centrum, it is just lucky. It will not work every time. For some reason, it works for this. So, and then you're done. So you get time period is equal to 2 pi root over 2r by g. You can check it out. What is the time period for a long pendulum? Do you guys even remember what is a long pendulum? Suppose if you take the planet and let's say if you put a pendulum which is very, very long, right? You should go back and check out the theory there, why this behaves differently than a normal pendulum. So when you displace this by theta, the problem is this. Mg is this thing. When you Mg will actually rotate, isn't it? Mg won't be vertical. It will not be vertically straight. It will be pointing like this. So the time period for this thing is 2 pi root over 1 by g into 1 by L plus 1 by R. Remember the formula? Where L is the length of the pendulum and R is the radius of the planet. And if you have L is infinity, that's the infinite pendulum. The time period becomes 2 pi root over R by G. This was a straightforward question asked multiple times. Find the time period of an infinite pendulum. People think it is infinity. Because we remember this formula, 2 pi root over L by G, so you think L is infinity. The formula is wrong. This is the actual formula. If the pendulum is very small, then 1 by R is negligible. Then you get your standard formula there. That's the formula for a long pendulum. So check it out the notes in case you don't remember what we did. This is the time period for infinite pendulum. That was a bitsmates, a very standard question, infinite pendulum. So they did ask even in medical NEET also. Time period of infinite pendulum. They never asked time period for a long pendulum. So that formula is better, you know. How to do this thing? This thing displaced by theta. So when you displace by theta, the spring force will be K into L theta. That is the spring force. This will be mg sine theta. That's your restoring force. So torque about this point will be mg sine theta into L plus KL theta into L cos theta is equal to minus IA alpha. For small angles, theta tends to 0. This can be written as mg theta L plus KL square theta is equal to ml square alpha. Alpha is, this is how we actually derived the time period for a pendulum, mg plus KL by ml. That's your omega square. Check. If this had been a rubber band, then what would happen? When you go to the left, it acts like a spring. When you come to the right, it becomes loose, it becomes a regular pendulum. So you'll take half of that and half of this. So rubber bands don't push. Clear with this. So displace by theta and finish it off with this. Torsional pendulum. I hope you guys remember this. Torsional constant is K, disk M and R. We have two cylinders, K1, K2. They are the torsional constants. Length is 2L, length L, R and 2R. Find the ratio of torsional constant. This question can be also asked in rigidity modulus. Third question, we have a disk, no slipping, mass M and R, and there's a spring. Find the time period for oscillations. Wait, I forgot something else. There is two more questions actually. What about this Dika question? What is the time period? As the shell of water is leaking, the center of mass will shift. So in the formula 2 pi root over L by G, L is the distance from the point of suspension to the center of mass. Clear? L is not the length of the string. L is the length from the point of suspension to center of mass. So initially when it is fully filled, half filled, filled, and finally empty. If you look at the center of mass, initially it is here, then the center of mass will come down, then it will come down, then it starts rising up and then comes back to the center. So if you actually look at the journey of center of mass, it goes down and then comes back, isn't it? Because when it is fully filled, it is center. When it is fully empty, it is at the center. So what happens to the length? Length increases and decreases. So time period increases and decreases. It comes back to the initial time period. It's pretty good standard question. L is not the length of the string. Be careful. What about this guy? It is a G effective question. So if you look at the pendulum here, what are the forces? Tension. The bind force will be rho liquid volume G. This will be rho B Vg. So tension will be rho B minus rho L Vg. That is equal to M into G effective. So we get G effective will be rho B minus rho L by rho B into G. So if you ask the pendulum, boss, what is your gravity? Pendulum will think this is my new gravity. You're getting it. Pendulum does not care whether you're getting the force due to the mg or the bind force. So the time period will be 2 pi root over L by G effective. Is that clear, everyone? So when you put the pendulum in the water, because of the bind force, it will start feeling little, the weight is less. So you can compare this with the G effective and you can say the gravity has changed. Mathematically, it doesn't make a difference for the time period. So you got the same answer. Clear? There, now get these three. Torsional pendulum, the formulas are pretty straightforward. So time period will be 2 pi root over I by k. बस इतना ही था. Where I is the moment of inertia of the system. So in this case, it is mr square by 2. And if you remember this thing, torque is equal to, the formula is this. Pi eta, eta is your rigidity modulus, r power 4 by 2L into theta. This is your torsional constant. It tells you how difficult it is to twist a rod or a body. So torsional constant is twisting torque. So you can clearly see K is proportional to R power 4 by L. So from there you can get the ratio. So if you have a rod which is thicker, it is the double radius is 16 times more difficult to twist. Longer rods are more easy to twist. How to do these kind of questions? If you remember, I taught you a trick for this. Replace the mass with a point particle at the point where this is suspended. Rotate this by theta. So this point will go by r theta. So that means this thing is pulling with k into r theta, that is your force. This is alpha. So k into r theta is equal to minus I alpha. So I will be I of the disk, which is mr square by 2, plus the particle, which is mr square. So the I is the moment of inertia of the system. Where is the particle plus this guy? Then you'll get the answer from there. Clear with that? So what is kr theta again? The change in spring force. Remember, initially spring is already elongated. We are always taking the change in torques and change in forces. Clear with this? Then comes this thing. Time period and different formulas. Electric dipole, torque is equal to P sine theta. Magnetism M cross B. Current loops, this one. This is the, remember what is this? Vibrational magnetometer. Yeah? So this is what I was saying. So if you see SHM now, we started with springs, then we said oscillations. Now you can see it is coming up in different chapters. Let's get these two. We have a container filled with a gas, helium, pressure P, temperature T, L and L, identical. In the middle, you have a smooth piston, mass M, area A, and insulated. If you disturb the piston will start oscillating. Find the time period for small oscillations. Thermodynamics and SHM. We have a mirror there, R20, a particle is oscillating, x is equal to 2 into 10 power minus 3 sine omega t. Find the amplitude of the image. Ray optics. Let's get them. The thermodynamics one is a good one. We did that in the class. Do you guys remember there's one problem, spring has a mass. Do you guys remember the result? The block of mass M and the spring ka mass is small m. Do you guys remember the result? You won't have time to derive in the exam if they ask you. It's mostly an advanced question, but who knows? Anyone remembers the result? The spring with a mass. 2 pi root over m is the mass of the block. You replace the spring with an m by 3 mass. Check it out. We did that with the energy ka thing. Remember this question? We have a spring of a block M and M. When you solve the whole thing, you'll get an answer like this. You can't solve this with force method. You have to use energy method to solve this. So check it out in case you don't remember this. But it's a good result to remember. You can just replace the spring with an M by 3 and finish it off. Yeah, we can't say, they can ask anything randomly and then people will cry, oh, this is an advanced question. What is the point? That's what I'm more scared of. You should be prepared. How to do this thing? So displace it by X. Now, when you displace this by X, what happens? The pressure will change. What kind of process is this? This is an adiabatic process. So when you displace this guy will be L minus X and this will be L plus X. This is an adiabatic process. PV power gamma is equal to constant. Differentiate on both sides. This will be dP V power gamma plus P gamma V power gamma minus 1 dV is equal to 0. So we get dP is equal to minus gamma d gamma dP by gamma P by V dV. So that's your dP there. So that means when you push this piston by X, the left hand side, the pressure increased, volume increased, so pressure will decrease, P minus dP into area. The right side, we compress, the pressure will become P plus dP into area. So the net restoring force will be 2 times dP into area is equal to mass into acceleration. This will be 2 gamma P by V dV into area is equal to mass into acceleration. But what is V? 2 gamma P, V is nothing but A into L. What is dV? A into X into area is mass into acceleration. 1A goes off. We get A is equal to minus 2 gamma P A by L into X into M. There. That's your omega square. Play with this. And I hope you remember what is gamma. Gamma is 1 plus 2 by F and it's a helium, so it's 5 by 3. I can make the question even better. Put one side helium, one side hydrogen, monatomic and diatomic. Still the same thing. And the formula will be gamma 1 P by V, gamma 2 P by V. You'll get gamma 1 plus gamma 2 instead of 2 ka value there. Clear with this? Thermodynamics and SHM. So you can play like this. Interesting today. From the starting till now, 8 people have increased in the batch. How do we do this thing? In ray optics, remember I taught you something? When the distances are small, we use differentiation. When the distances are big, then you take the extreme positions. So 1 by V plus 1 by U is 1 by F. Differentiate on both sides. You end up with minus dV by V square minus du by U square is equal to 0. So dV will be minus V square by U square into du. So in this, what is du? This is your object displacement. So since you want the amplitude, so take this guy as 2 into 10 power minus 3. So then automatically this will be the image amplitude. And you can find V and U normally. Is that clear? So whenever the distances are small, how do you know it is small? Compared to the radius, which is in centimeters. If you have millimeters, use this formula. But if this thing is not 2 into 10 power 3, but it is 2 centimeters, then you're dead. Then we will take 20 plus 2, 20 minus 2, 2 positions, and then take the extremes. But problem ye hoga that image ka oscillation, right? Then it will be unsymmetrical. Amplitudes won't be same. So then saying find amplitude doesn't make sense. And that is the reason I was careful. I said find approximately. Clear with this? Take a break. Come back by 9:40. We'll continue from here. Go get away from the screen for 5 minutes and then come back. Sure, let's start off. Let's get this thing. Inductor and a rod, and there's a magnetic field. Find the time period. Electromagnetic induction. How do you handle this? If you guys remember, in this there are three models: resistor, capacitor, inductor. You can keep a resistor there, you can keep a capacitor there, you can keep an inductor there. If you put a resistor, it behaves like that, a viscous force Varroa equation, terminal velocity at infinity. You put a capacitor, you get a constant acceleration. If you put an inductor, you get SHM. Let's see. There is no resistance. If there is resistance by, it will be an SHM. If there is resistance, then energy will be dissipated. Then it will be a damped oscillation. So after some time, let the velocity be V. If you have a rod placed in a magnetic field, it will act like a battery, which will be BLV. This will send a current I. Then you write BLV minus L di by dt is equal to 0. Then if you draw the rod guy FBD, you have mg, you have ILB. And acceleration. mg minus ILB is equal to ma. Differentiate on both sides. This will be minus LB di by dt is equal to m into d square v by dt square. But what is di by dt? Di by dt is minus LB. Di by dt is BLV by capital L. So if you look at this, we get d square v by dt square is equal to minus b square L square by m capital L into v. This looks like an SHM equation where v is equal to v naught sine omega t plus phi. and omega is this guy. Omega is root over b square L square by ml. Luckily, I asked you only for the time period, so time period is 2 pi by omega. Job's done. But let's find the amplitude also. So time period is done. So you got that. So can I find v naught? Can I find phi? Can you find the displacement of this rod as function of time t? Now the question suddenly goes up into the advanced part. This is a pretty good one though. How do we do that second part? So v naught sine omega t plus phi. So at t is equal to 0, your velocity was 0. Therefore, phi will be 0. So v is equal to v naught sine omega t. How do I find v naught? Differentiate this. dv by dt will be v naught omega cos omega t. At t0, the rod is yet to move, so the current is 0. So on the rod, you'll have mg and ILB is 0. So acceleration is equal to g. So at t is equal to 0, acceleration is equal to g. That will be equal to v naught omega. Therefore, v naught is equal to g by omega. This is how you find that v naught. Now you're done. So v is equal to g by omega sine omega t. This is your velocity as function of time t. Now integrate this again. Dx by dt, x is equal to g by omega square. Sine omega t ka integral will be cos omega t. 0 to t limits. That would be 1 minus cos omega t. That's your position as function of time t. So you can arrange this a bit. This will be x minus g by omega square is equal to g by omega square sine omega t plus phi. This is your x mean. This is your amplitude. Clear with this? Amplitude, you could have got it even faster actually. V naught is equal to a omega. From there, you would have got the amplitude. But this is how you find the position as function of time t. Clear with this? Pretty good question, but yeah, mostly an advanced paragraph. Let's get this thing. Y is equal to 10 cos square pi by 3x minus pi by 60. Wave equation, everyone. Find V wave, lambda, frequency, amplitude, phase difference between 2 and 3. We have a photograph here. This is the snapshot at t is equal to 0. Using this information, find the wave speed. Y is equal to this equation, find the wave speed and the amplitude. Let's see. There you can see the general equation there. You know how to do. Convert this. So this will be y minus 5 is equal to 5 sine 2 pi by 3x minus pi by 3t plus that would be pi by 2. 1 plus cos 2 theta and 90 plus this. Yeah, that's it. There you get amplitude, everything yet. What else you want to find? Find the phase difference between x is equal to 2 and x is equal to 3. You guys remember the phase difference ka formula? Pi is equal to 2 pi by lambda into delta x. Remember, this is only for progressive wave. For a stationary wave, you can't use this. Remember? In a stationary wave, what is the catch? All the points within a loop are in phase. Alternate loops are out of phase by pi. But there are only two answers there. This is not valid for this. So 2 pi by lambda and delta x will be between 2 and 3. So that's 3 minus 2 and you're done. What is this formula here? V wave is equal to minus, reverse I wrote, V particle is equal to minus V wave dou y by dou x. Remember this formula? Quite an important formula, one of the most neglected one. What about this thing? V wave is nothing but coefficient of time by coefficient of x. Hope you remember with that. So, or you can even say like this thing. This is like kx minus omega t. So V wave is equal to omega by k, which is 2 by 3. Minus indicates it is traveling in the positive x-axis. What is the amplitude? The maximum, this thing. So we get amplitude. Y is maximum, where denominator is minimum. So 3x minus 2t must become 0. Therefore, amplitude is 5 by 2. Clear with this? So this is not a sine wave, but this is a wave equation. Do you guys remember for a wave equation, there are three conditions? It should in the be form of kx plus or minus omega t. Second thing, it should be continuous and differentiable. The double differential should be valid. Dou square y by dou t square is equal to v wave square dou square y by dou x square. Third one, the function should be finite for all x and t. It should be a bounded function. Those are the three conditions. Let's get these two. So that's a y-x graph. Huh? So that's a wave. It's a transverse wave on a string. Find the direction of velocities of A, B, C, D. So there are 4 points on a string and the wave is going to the left side. How are these 4 points going? Up, down, right, left. These are 4 options. Hoga. Second thing, there are two tuning forks, one kept vertical, one kept horizontal. Mass is m and 2m, amplitude A, mu and 2 mu. Find the ratio of power transmitted in the string. I taught you a shortcut for that if you remember. The one way to do this thing is we can use this formula minus Vp is equal to minus V wave dou y by dou x. Safe, you get the answer. So V wave is negative here. So if the slope is positive, particle is going up, slope is negative, particle is going down. But there is a much faster way. Since the wave is going backward, just draw the wave a little to the side. So after a little time, the wave will going to become like this, the red line. You can clearly see the picture. ABCD will always go up and down because it's a transverse wave. A must have gone down, B must have come down, C must have come down, and D must have gone up. Easy. Just push the wave a little and see where the particle would have been there. In a transverse wave, particles always go perpendicular to the oscillation. What about the second thing? You guys remember the power curve formula? P is equal to half mu a square omega square v wave. What is the frequency of the wave here? 2f. Do you guys remember this? What is the frequency of the wave here? F. Depends on how you keep the tuning fork, frequency changes. याद आया वो? When you keep it the tuning fork vertical, you get double the frequency. This is something which we discussed quite in the beginning actually of waves mein. There, remember this thing, case 1? When you keep it vertical, in one half oscillation, you'll get a full wave. The frequency of the wave is double. If you keep it horizontally, you get the same frequency. So, simple thing, but yeah, people forget. And what is the wave speed here? So, hope you remember wave speed ka formula. V wave is root over T by mu. So, this is proportional to amplitude square. Omega is F square. V wave is root over T by mu. So, that would be root mu. There, this is the ratio. So, P1 by P2 will be amplitude will cancel off. 2F ka whole square root mu. Tensions are also different actually. This is also root T. This is root mg by f square root over 2 mu root 2 mg. So you'll get the answer. Let's get this thing. We have a lift which is going up with 2g. Inside there is a rope which is hanging. Mass m length L. If you generate a pulse at the bottom, find the time taken to reach the ceiling, find the acceleration of the pulse. We have a string here, mass is 2 grams, length is 2 meters, 4 kg block, third overtone, find the frequency. Stationary waves. Hope you guys remember that string ka there is a direct formula. Let's see. What is the formula for this? The acceleration of the pulse will be g effective by 2. Check out the formula there with the derivation. The pulse will be, going with an acceleration of g effective by 2. So here, what is the g effective? G effective is 3g. 3g by 2. And what is the length L? L is equal to half into a into t square. That will be half into 3g by 2 t square. You'll get the time from there direct. If you know the result, it is straightforward. When you generate a pulse at the bottom, it behaves as if it has a constant acceleration of g by 2 while going up. Is that clear? A better question would have been this. Generate one more pulse on the top. Find the position where the pulses meet. That would have been a better question. But okay, you got it. What about this guy? So, I hope you remember the formula. F is equal to n by 2 well root over t by mu. Direct formula substitution. Third overtone, matlab fourth harmonic. Length of the string is 2 meters. Tension is equal to 40. Mu is what? Mass per unit length in kgs. So be careful, don't write 2 directly. That is 2 into 10 power minus 3 while length is 2. Clear? Don't write it as 2 by 2. It's not 2 by 2. It is 2 grams that is. You have to write in kgs. So yeah, be careful with that. And then you'll get the answer. You're done. Then not tough, but you should know your results. Let's get these two. We have a square pulse. Again, imaginary shapes. These things don't exist, but for the sake of 1 meter per second, length is 1 meter, ring is adjacent to 1 meter. It's a massless ring. Draw the shape at 1.75 seconds. We have a wave going from heavier to light string. Find A reflected and A transmitted. Let's see. So 1.75 seconds, what will happen? 3/4 of the wave must have already got inverted, right? So if I draw the picture, it would look like this. So 1/4 is still going, and 3/4 of the wave. Remember, it is a massless thing, so it will be invert. It will not get inverted. So the resultant will look like this, isn't it? So this part will be half. This part will be 1/4, and this height will be 2a. So wherever the incident and the reflected overlap, it will become double. And I hope you remember the formula for this. A reflected is V2 minus V1 by V2 plus V1 into A incident. A transmitted is 2V2 by V1 plus V2 into A incident. Check out the notes, direct results. So here V1 will be the left one, root over T by 4 mu. You can take it as V, then V2 will be root over T by mu. This is 2V. Substitute, you get the answer. Clear with this? Let's get this thing. So we have a wave on a string A, B, C, D. There are 5 points. At which point potential energy is maximum, kinetic energy is maximum for a small segment dx. Stationary wave, length of the string is 30 centimeters. Find the harmonic, find the phase difference between 2 and 3, and find the wave speed. What are the catch? It is a wave on a string. So the highest points will have zero velocity. So this is zero. So this will have kinetic energy minimum. So when you say potential energy is maximum, we are talking about elastic potential energy, right? So basically at the nodes, at this points, right, the string is stretched maximum. So here the point is stretched maximum. So here the potential energy is maximum, right? And also it is at, it is also at the mean position. So kinetic energy is also maximum. At this point, right, kinetic energy is zero and potential energy is also zero. Clear with that? The point B will have both zero and point D will have both maximum. Energy is not conserved in a progressive wave. Hope you remember, energy is being transmitted. What about this guy? This is K, this is omega, so wave speed will be omega by K. Length is 30 centimeters, K will be 2 pi by lambda, which is pi by 3. So lambda is equal to 6 centimeters. So length of one loop is lambda by 2, 3 centimeters. So this 30 centimeters will give you 10 loops. This is the 10th harmonic. And if each loop is 3 centimeters, you kept one point at x is equal to 2 and one point at x is equal to 5. There are alternative loops, so the phase difference is 3.5, sorry. So phase difference is pi. Clear with this? Let's get these two. If the harmonic changes from third to fourth when you immerse in the liquid. So before immersing it is third harmonic, after immersing it becomes fourth harmonic. Find the density of rho b by rho l. Second thing, you kept two bridges in the middle and you got three strings. And the frequency is 1 is to 2 is to 3 in fundamental frequencies. Find the position of the bridges. So when you keep a bridge, you're dividing into the strings. How do we handle this? Let's see. So you're going from third to fourth harmonics. So let's see the formula there. So f is equal to n by 2l root over t by mu. You didn't change the frequency, you didn't change the length, you didn't change the mu, but n and t are changed. So n into root t is constant. So n1 root t1 is equal to n2 root t2. You're going from third harmonic and the tension initially was rho b Vg. You enter the fourth harmonic, now the tension is rho b minus rho l Vg, the bind force subtract curve. You'll get the answer. What about this thing? All these are fundamental frequencies. Again, f is proportional to 1 by L. So 1 is to 2 is to 3. Then you get L1 is to L2 is to L3 is 1 is to 1 by 2 is to 1 by 3. That is 6 is to 3 is to 2. Then you're done. So this length will be, how much is that? 6 by 11 into 100. 6, 3, 2, 9, 2, 11. Yeah. I should have given maybe 110 centimeters, I guess. That would have been a good number. That would be 60 centimeters. So this position is x is equal to 60. The next guy is 3 by 11. That is 30 centimeters. So this is x is equal to 90. And then there, x is equal to 110. Clear with this? So the bridge must be placed at 60 and 90 centimeters. Clear with this? So that's a good one. They can play like that. Position of the bridges. They don't ask you the length of strings. So people will write it as 60 and 30. So be careful. Let's get this thing. Composite string, yeah? Thick string and a light string connected to the block. Find the fundamental frequency. If length of the wire decreases by 20%, tension increases by 44%, radius of cross section increases becomes half, what happens to the frequency? I messed up everything. So what is the catch in these kind of questions? When you have a composite string, the catch is this. That point of intersection cannot move. If that point moves, you start generating a reflected and a transmitted pulses and the whole setup goes off. So this point has to be a node. That is the main catch in this question. Then you're done. You can treat them as two different strings. Let there be n1 loops, let there be n2 loops. So frequency will be n1 by length L, root over tension is same 4 mu. This is n2 by length L, root over tension by 9 mu. So we get n1 by n2 is equal to 2 is to 3. What is the meaning of this? The meaning of this is whenever you get stationary waves on this, you have the ratio of loops is always 2 is to 3. So the fundamental frequency will be this. So we have 3 loops and we have 2 loops. That means the second harmonic of the 4 mu string and the third harmonic of the 9 mu string, that is the first time when they will exactly match their frequencies. Getting it? So that will be the fundamental frequency of the system. Is that making sense? So second harmonic of this, so when n1 is equal to 2 and n2 is equal to 3, that will be the fundamental frequency. That will be 2 by, I think there's a 12 also here. Root over 2 by 4 mu. Done. What happens to the frequency? Okay, length I can understand. What happens to the radius of cross section? How does that affect? What is mu? Mu is rho by area, remember? Mu is mass per unit length, that will change. So this will be rho by pi r square. So whenever you mess up the radius, this thing mu changes. So F is equal to n by 2L root over T by mu. Tension becomes 144, so that is 1.44 T. Length becomes 0.8 L, and mu is proportional to r square, so r square by 4. That is 1.2 by 0.8 into half. That is 0.4 is equal to 3. It becomes 3 times. Is that clear, everyone? Do not use that error ka formula dt by t plus dl by l. Why? The errors are huge, 20%, 44%. You can't use that formula. That error ka power rule is valid only for small errors. It's clear with this. Let's get this one. We have an open pipe and an open closed pipe. The fundamental frequencies are F1 and F2. If you combine them, what is the new frequency? In an organ pipe, if nitrogen is replaced by helium and the temperature is doubled, what happens to the speed of sound? If pressure becomes 4 times, what happens to the speed of sound? Shouldn't mu be 4 times? So that is root mu, na? The radius becomes half. Okay, I wrote reverse. You are right. Mu is proportional to 1 by r square. So this will become 2. So 1 by r will go up, no? It will become into 2. Yeah, so that would be how much then? I still got 3 only. I think previous one was wrong. No, I messed up something. 2 will... if r becomes half, mu becomes 4 times. Okay, I'll just write it here only. 4 mu into 2. That's 12 by 8 into 2, 6 by 8. 3f by 4. That's right? Yeah. Let's get this. Finish off. Last one for the day. Let's see. So for an open pipe, what is the formula? F1 is equal to NV by 2L. For a closed pipe, what is the formula? V by 4L. 2N plus 1 V by 4L, if you remember. So when you make it one thing, it still becomes a closed pipe. So this is L2 and this is L1. This length becomes L1 plus L2. So this F will be V by 4 L1 plus L2. So take L1, L2 from here and substitute. This will be V by 4, L1 will be V by 2 F1 plus L2 will be V by 4 F2. V gets cancelled everywhere. You can solve this. This is 2 by F1 plus 1 by F2. So F1 plus F2 by 2 F2 plus F1. That's your answer. In an organ pipe, if you replace the, what happens to the speed of sound? What is the speed of sound formula? Root over gamma RT by M. So you're messing up multiple things here. You're messing up gamma because for this guy, gamma will be 1 plus 2 by F. It's a diatomic. That is 7 by 5. And for this guy, gamma is 5 by 3. You're messing up the molecular weight also. This is 28 and this molecular weight is 4. Yeah, and temperature also you messed up. So you can solve from there. What happens to this thing? C is a very good question. Came up multiple times. Anyone remember the answer? Nothing happens. Speed of sound is independent of pressure. It depends only on temperature. If you remember the formula, root over gamma P by rho, right? P by rho is RT by M. If you increase the pressure, even rho increases. If P increases, volume decreases, so density increases. So P by rho remains constant. So unchanged. Speed of sound depends only on the temperature. It's independent of pressure. Quite an important thing. Don't forget that. It is asked a lot of times. Clear this? Yeah, that's a bit about the waves and all. So next class, when we catch up, we'll continue from here. We will do a few more of this and then we'll start off with thermodynamics also. I'll see you guys again on Monday then. So yeah, any doubts, anything else, please stay back and ask, or else you're free to leave. And do remember, I uploaded 5 more speed tests. So they are online till April. So anyone wants to do additional practice, you can do, but not compulsory. Getting it? So focus on your solving your material, focus on writing full syllabus papers. That's your top priority. Finish your material, right? Maths, physics, chemistry, give equal time, whichever is your weak subject, study that. Inorganic ratta maro, that is more important. So just because there are papers, just because there's a content doesn't mean you should do everything. See what works for you. You don't know what works for you, you're confused, talk to a respected teacher, get sorted, and then go. Getting it? And it is not like, ek bar plan bana liya, to, that is the same plan every 2 weeks or 1 week, right? See, as long as you're studying more and more, you will start realizing, okay, this is not working, this is working. So plans need to keep changing, getting it? You can't have a fixed plan till the end. So yeah, so keep talking to respected teachers and make sure someone is monitoring what you're doing.